Report writing guidelines for Experiment 2, Projectile Motion. Please write your experiment report in the lab report writing session provided in the Physics Practical Workbook. Learning outcomes. At the end of this session, students should be able to determine the acceleration due to gravity G using projectile motion. A warm reminder, all the values shared under the observation are just for your reference to ease the explanation. You are not allowed to copy and use the values for your experiment report. Any values found the same in your experiment report are against the scoring rubrics as no plagiarism is allowed. You must write your own lab report. You are not allowed to copy your peer's experiment report. Any doubts found in the originality of your experiment report are against the scoring rubrics. Observations. Data tabulation. Make sure all the column headers are labeled properly with the physical symbols and units. The number of decimal places for primary data must follow the sensitivity of the instrument used. The number of decimal places for secondary data are rounded off to consistently 2 or 3 decimal places. In general, the centroid is written as mean x, mean y. We are plotting graph of h against r squared. Therefore, the centroid of this experiment is written as a mean r squared, mean h. Calculate the mean of r squared and mean of h. And the central point will be 4.25 times 10 to the power 3 cm squared, 32.5 cm. Remember to mark the central point on the graph of a h against r squared. Then circle it to differentiate the central point from the other data points. Plot graph of h against r squared. First, the title of the graph is written. Then, the y-axis is labeled with units, and x-axis is labeled with units. The size of graph is more than or equals to 50% of the graph paper. All data points are marked correctly on the graph. Appropriate scales are used for both sides. For example, 1, 2, 3, 2, 4, 6, 5, 10, 15, 10, 20, 30. A balanced best fit line through the central point is drawn. Sides x and y of the triangle of gradient are more than or equals to 8 cm. Central point is marked and circled. This is an example of the not balanced fit line. The left of the graph and the right of the graph. Below the central point, above the central point. Determine the gradient of the graph. For the operation of addition and subtraction, the number of decimal places of the x and y entries must be consistent. M best equals to y2 minus y1 over x2 minus x1. The number of decimal places that we need to put, it depends on half of the smallest division of the scale used for both x and y axes. Based on the graph plotted in the previous slides, for the y-axis, 10 divisions between 0 and 5. Half times the smallest division of the y-axis will become 0.25. that consists of 2 decimal places. For the x-axis, 10 divisions between 0 and 1. Half of the smallest division will be half times the smallest division of x-axis. The answer is 0.05, consists of 2 decimal places as well. For the operations of multiplication and division, the least number of significant figure of the x and y entries is considered and reflected in the calculated value of gradient m obtained. For example, 52.50, 4 significant figure. 7.00, 3 significant figure. 7.10, 3 significant figure. 0.60, 2 significant figure. Among the x and y entries, the least number of significant figure is 2. Can be allowed to add one more significant figure, become 3 significant figure. Therefore, the value of m is rounded off, becoming 7.00 times 10 to the power of -3 per cm. This is the example of the uncertainty of gradient delta m by using Excel. Fill up the column x with the values of r squared. Fill up the column y with the value of h. Fill in the value of gradient m obtained from the graph. Lastly, the delta m calculated by Excel. Please record it down in your workbook. Please round off the value of delta m to the same decimal places as m obtained. m best equals to 7.0 times 10 to the power of -3 per cm. Delta m equals to 0.0006 per cm. Therefore, change it to 0.6 times 10 to the power of -3 per cm. Thus, m plus minus delta m equals to 7.0 plus minus 0.6 times 10 to the power of -3 per cm. Both also 1 decimal place. Determine the acceleration due to gravity g using the projectile motion. From the equation 2.5, h equals to 7 over 10 r squared over gt squared. Compare with the linear equation y equals to mx plus c. The formula of gradient m best equals to 7 over 10 gt squared. Therefore, the acceleration due to gravity g equals to 6.49 meter per second squared. Based on page 2 in the Physics Practical Workbook, deduce the formula of delta G using the combinations of uncertainties. M best equals to 7 over 10 GT squared. Bring the G, become subject, which is G equals to 7 over 10 M best T squared. And become delta G over G equals to delta M over M best plus delta T squared over T squared. How to get 15.4 times 10 to the power of -2? Due to the h is 78.5. Labels the 78.5 at the graph of freeform motion, which is h against t squared. And the graph at the end will show the t squared is 15.4 times 10 to the power of -2 second squared. Due to the smallest division is 0.2 times 10 to the power of -2, but half of it, and the delta t squared become 0.1 times 10 to the power of -2. And the final answer, delta G, equals to 0.60 meter per second squared. The result obtained, G plus minus delta G equals to 6.5 plus minus 0.5 meter per second squared. Why 6.5? Always round the experimental measurement or result to the same decimal places as the uncertainty. Why 0.5? Experimental uncertainty should be rounded off to one significant figure. How many digits should be kept? To be consistent with this large uncertainty, should be stated to only one significant figure or perhaps two significant figures if the first digit is a 1. Experimental uncertainty should be rounded off to one or the most two significant figures. For example, 9.23 plus minus 2.22 cm is incorrect. We should write 9 plus minus 2 cm because the delta m is not start from 1. Always round the experimental measurement or result to the same decimal places as the uncertainty. For example, 9.23 plus minus 2.22, and the correct answer should be 9 plus minus 2 seconds. The second example will be 9.23 plus minus 1.22 seconds. Due to the delta m start with 1, therefore, you can write 9.2 plus minus 1.2 seconds can up to 2 significant figure. Calculate the percentage of uncertainty. The formula is delta G over G times 100%. And the answer will be 7.7%. And then calculate the percentage of difference. The formula is modulus actual value of G minus the experimental value of G divided by actual G times 100%. The answer is 33.74%. Discussion. State the results obtained in the form of G plus minus delta G meter per second squared, the percentage of uncertainty, and the percentage of difference. State the possible errors occurred in the experiment and elaborate. State the precaution step taken in the experiment. Conclusion. State whether the learning outcomes or objectives of the experiment could be determined by the experiment. A warm reminder. Please check with your lecturer when to submit your experiment report, as your lab report will be evaluated based on the report writing skills score rubrics provided in the Physics Practical Workbook.